Okay, today we're going to go over 3.2 and 3.3. There's no school tomorrow, and Friday you will have your Chapter 3 quiz. Friday from 11:50 to 12:50 is when you will take your quiz. I will send you your quiz exactly at 11:50 on Google Drive. I will share it with all of you. And you must send it back to me completed. So you have to copy it. What you're gonna do is you're gonna copy, and you're gonna paste into your own document, Google Docs document. It must be Google Docs. Into separate Google Doc. Separate Google Doc. The title of the doc, the title must be exactly like this, Q3, and then underscore, and your name in all caps. That's how you must title your doc. Then not exactly, but before 12:50, you must share your doc with me. And you may not I can go back and see when you edited the doc. So after 12:50, you cannot edit the doc again. If you do, you'll lose points. For every minute, so let's say you submitted it at 12:50, but at 12:54 you had made some edits, then that's 4 points off of your quiz because you're submitting it basically 4 minutes later. So you must be done at 12:50. You must have it shared with me before 12:50. I would say start trying to submit it by 12:45. Okay? All right. So that is it. That's how we're going to do the quiz on Friday. If you have any questions about that, please let me know so that we can address them before you're taking your quiz on Friday. Okay? All right. Here we are on 3.2. We're going to talk about Newton's laws of motion. So you need to know about Newton's first law. Remember that it's also called the law of inertia, and it states that an object moves at a constant velocity unless an unbalanced force acts upon it. When an object is at rest, it stays at rest, and an object in motion will stay in motion until it's acted upon by an outside force, or we also call it an unbalanced force. Okay, so you're going to need to be able to identify this in a word problem or a given scenario, like how we did the other day. So if you have problems with that, you can go back to previous assignments, look at the keys, and get some help that way. Specifically, the Newton's laws review questions. Those are going to be really good questions that you might see similar ones to on the test or the quiz. So, okay, what is inertia? Remember, inertia is the tendency of an object to resist change in its motion that it already has. So it could be the resistance to starting motion. So if something is at rest, it's the resistance to starting motion, and if something is already moving, it's the resistance to stopping. Remember that mass and inertia are related. As mass increases, so does inertia, and as mass decreases, so does inertia. So this is a direct relationship, or a directly proportional relationship between these two. And as mass increase, so another way of saying this, like I've written here, is that as mass and inertia increase, the force you need to change the object's motion will also increase. If you think about a big, huge truck, right? If it's going, it has a lot of inertia, right? To start that truck and to make it move, we need a lot of inertia or a lot of force to get it going, as opposed to a little tiny motorcycle or a bicycle even. That's one of those two. That's something, yeah, that's really a nice bike, isn't it? Okay, as opposed to this, with a little tiny mass and a little tiny inertia, not a lot of force is needed to change this bicycle, to make this bicycle start moving, right? You don't have to it doesn't need an engine if it's a bicycle. It doesn't need an engine to start moving, right? We just need to push with our legs. Whereas if you pushed with your legs on the truck, that's not going to be enough force to get the object, the truck to move. So this is how mass and inertia are related. And we need to talk about how inertia is different. Where did I put that? Over here, maybe? Inertia is different from momentum. Here we go. Okay, so remember that momentum, this is the equation for momentum that we're going to see later also. And momentum is equal to the mass, the product of the mass and the velocity of an object. So a change in momentum can be produced by increasing or decreasing our velocity, right? We could also increase or decrease our mass, but we could also increase or decrease our velocity. With inertia, we can't change the inertia of an object unless we totally change the mass of the object, right? So like my inertia can't change unless I increased my mass or decreased my mass, right? Whereas my momentum could change. All I'd have to do to change my momentum is to walk faster or walk slower, run faster or run slower, right? Okay, so that's Newton's first law. That's everything on the study guide that you need to know about the first law. The second law states, Newton's second law states that when an unbalanced force is applied to a mass, the object accelerates either negatively or positively. That's the one that's from your book. I don't really love that definition, so we're going to go with this one. The acceleration of an object is dependent upon two variables. It's dependent upon the net force acting on the object and the mass of the object. And even a better definition would be this one underlined in red here. So this is the one that I want you to know for your quiz. This is the best definition of the second law. It states that an object's acceleration is in the same direction. That's a very important part. It's in the same direction as the net force on the object, and it's equal to the net force divided by the mass. Okay, so if we look at the relationship between force and acceleration, they are this is a directly proportional relationship. As force goes up, acceleration goes up. So if we increase the force, we increase the acceleration. If we increase the acceleration, we are having an increase in velocity, right? So I gave you an example, I think, of hitting a ball it was throwing a ball as hard as you can versus tossing the ball just really softly. So if you throw the ball as hard as you can, you're going to have an initial velocity of 35 meters per second, let's say. Okay, super hard throw. By the time the ball is at the end of its path, it will be 0 meters per second. At its final velocity will be 0 meters per second because it will come to rest, right? So this total change in velocity is 35 meters per second, because remember, to find the change in velocity, which is just final velocity minus initial velocity, we would just subtract 0 minus 35. So there's a change here of 35 meters per second. Remember that acceleration is change in velocity divided by time, right? So if this took 1 second, then your acceleration would be 35. But with this let's say when we just toss the ball, soft toss of the ball, we're using a small amount of force. Let's say when we use this small amount of force, we throw the ball with only 10 meters per second. That's our initial velocity. And of course it comes to rest, so that's our 0 meters per second at our final velocity. This change in velocity is 10 meters per second. And again, let's say that the time is the same. Let's say that it takes 1 second. So that's 10 divided by 1. So this is going to be an acceleration of 10 meters per second squared versus an acceleration of 35 meters per second squared. So this is an increased acceleration, right? It has a larger change in velocity, therefore it has a larger change in acceleration, therefore it has a larger force. Okay? All right, so this is a directly proportional relationship. If you want to increase the acceleration, you have to increase the net force. Okay. And then you also need to know about the relationship between mass and acceleration. So this is an inversely proportional relationship. You can see I've written that squished on the side here. it's an inversely proportional relationship. What that means is that as one goes up, the other goes down. So as we increase mass of an object, we decrease its acceleration because we're decreasing its change in velocity. Same with decreasing mass. If we have a small mass, we can have a fast acceleration. And this makes sense just thinking about objects that you've seen in the everyday world. If you kicked if you tried to push a bowling ball versus, or let's say throw, we'll stick with throwing. You're going to throw a bowling ball versus throwing a ping or a tennis ball. Which is going to have the faster acceleration? Which is going to go the farther distance? Which is going to have the higher speed? Well, the tennis ball is, because it has a smaller mass, right? And smaller mass means that you have a greater acceleration, which means that you have a greater change in velocity, meaning you can have higher speeds, right? Okay, so that's all you need to know about mass and acceleration. The last thing for the second law is you need to be able to manipulate the formula for the second law, and you need to be able to identify that the second law is occurring given a word problem or scenario. So same thing that Newton's laws review questions. Those are posted. The key is posted on Friday, the 16th of October. I would recommend looking at those questions because those are going to be helpful, and that explains kind of what I'm looking for you to be able to identify given a word problem or scenario. So if you had a question about that, go to Friday the 16th of October, that assignment, and the key is on there, and you can look at that. You can look at the questions and the answers. Okay, so you need to be able to manipulate this equation. Remember that our equation for the second law is that acceleration is directly proportional, right? It equals force. That makes sense. That's a directly proportional relationship. Divided by mass. So A equals F, okay, directly proportional, divided by M. So this is the inversely proportional part, right? So you need to be able to manipulate this equation, solve for word problems using this equation. You can also memorize it like this if you want. This is how we see it sometimes. Force equals mass times acceleration. But this is the more correct way for depicting Newton's second law. Okay, so if you want to, if you need help with word or math problems for Newton's second law, you can go to the same week on Wednesday, the 14th of October, and I do some problems regarding Newton's second law on there. So if you are struggling or you want to see these word problems done, then you can go to Wednesday the 14th. Okay, finally, Newton's third law. His third law states that when one object exerts a force on a second object, the second object exerts a force on the first object that is equal in strength and opposite in direction. Another way of saying this is that for every action force, there is an equal in size and opposite in direction reaction force. So remember that if I push on the wall, I was pushing on the wall with both my hands with 30 newtons. Well, I don't fall through the wall, right? So that means my net force must be 0 because there's no movement when I'm exerting this force. So what causes a balanced force to occur is a reaction force pushing in the exact opposite direction with the exact same magnitude. So my action force is going to be me pushing, and the reaction force is going to be the wall pushing on me. Okay, so that's pretty, I think that's pretty straightforward. If you want more, here we go. Here's a couple other examples. The action force would be the person's foot pushing down on the floor. The reaction force is the floor pushing back up on her foot. Here, in this situation down here, I didn't like guns, so I canceled out this one, remember? So here, the action force is the boy pushing off of the boat, and the reaction force is the boat pushing back on the boy. All right, so I think this is pretty straightforward. Again, Friday the 16th, if you need more examples or you want to look at that homework that had that was identifying the different laws in given scenarios. That would be a good assignment for you to look at. Okay, we've gone over Newton's laws. Now we're going to look at how we use his laws in everyday events like crashes, falling objects, and collisions. So we just went over his first, second, and third law, so I'm not going to read this part or go over that part again. But we will first talk about crashes. So you need to be able to discuss and explain how Newton's first law can be applied to a head-on collision or crash. So remember that the people inside, if in a car accident, if it's a head-on collision, let's say that it's running into this wall, the car is, it's going to go from 60 kilometers per hour to 0 kilometers per hour in a really, really super tiny amount of time. And the car is going to crumple and it's going to smash and be all crushed. But the people inside the car, they're going to also be traveling at 60 kilometers per hour, right? And they continue moving forward at this speed because of Newton's first law, which is the law of inertia. And remember that it's when objects are in motion, they stay in motion unless acted upon by an unbalanced force. And in this situation, the seatbelt is the unbalanced force that prevents the object, which is the human, from continuing to move forward. So the seatbelt stops Newton's first law from, well, it doesn't stop Newton's first law from being true. It stops the object from continuing to move forward. So the seatbelt is the unbalanced or the outside force that Newton's first law addresses. So what the seatbelt does, remember, is it slows the person down and prevents the forward motion. So if we don't have on a seatbelt, I didn't go over this. Yes, I did. Yeah, well, I guess I just didn't draw pictures or write any notes about it. I guess must have just talked about it. So remember, if we don't have a seatbelt, what occurs? If there's no seatbelt, then this law is, it's still true no matter what. So we don't have an unbalanced force or an outside force acting on the person. So the person will continue going forward. They might go through the windshield. If they're in the front seat, they might hit the back seats if they're in the back seat, or they might hit the front, the backs of the seats if they're in the back seat. So that's the importance of seatbelts in this scenario. Okay? So that's what you need to know about crashes. The second one was falling objects. So you need to be able to discuss how Newton's second law can be applied to falling objects, and you need to be able to use the acceleration equals the net force divided by mass equation to explain the acceleration of a falling object. So remember that that objects in free fall, we said that the only force applied to a free falling object is the force of gravity. And the reason that we said that is because air resistance is small, but it still exists. Air resistance is another force. It's the force that pushes back on an object as it's falling downward. So we said that in most physics classes, until you get to 12th grade, the only force that's applied to a free-falling object is the force of gravity. And we said that, and we derived this equation. Remember that we said acceleration equals, we went through all of the manipulation of this equation, and we brought it down to equal acceleration equals strength of gravity, which is acceleration due to gravity. So we came up with 9.8 meters per second downward. But I said this isn't technically true, but that's what we're going to assume. So for on the quiz, if I say, what are the two forces that act on a free-falling object? Well, it's the force of gravity and air resistance, because air resistance, remember, is the force that is opposing the motion of falling objects or objects moving through the air. They don't have to necessarily be falling. But it's so tiny, and to make this number be correct, we sometimes in physics classes they say that the only force acting is gravity, but I'm not going to say that because it's kind of a lie. So, okay, remember that we have this thing called air resistance, and the thing that what air resistance, I already told you what air resistance is, but the main thing that determines the amount of air resistance that an object feels is its surface area. And remember, again, there's a direct relationship between surface area and air resistance. As we increase... Sorry, I said that wrong. Why do I have that written like that? There we go. Okay, this is an easier one. It is a direct relationship, but there's an inverse relationship between the speed and the surface area and air resistance. So there's a direct relationship between surface area and air resistance. If I increase my surface area, then I increase my air resistance. Like this huge elephant has a lot of surface area, right? A lot of area that covers its body. That means that large surface area, it's going to feel a lot of air resistance because there's lots of different places for the air to push back on this elephant that's falling. What that means, these two things mean that the speed with which the elephant will fall will be smaller than, for example, this tiny little penny, which has a small surface area and a small air resistance. Because there's less surface area, if these two things were dropped from a plane at the same time, the penny would hit the ground first. It would hit the ground before the elephant because it has a higher speed. The reason it has a higher speed, lower surface area, lower air resistance. You can think of air resistance as the opposite. It's like slowing down. It's like putting brakes on something that's falling. Okay? So that's what you need to know about the main thing that determines air resistance and the relationship between surface area and air resistance. Our final piece from chapter 3 that you need to understand is how Newton's third law can apply to collisions. Remember that Newton's third law states that for every action force there is an equal but opposite reaction force. So we have this thing called the law of conservation of momentum, which cannot be true if Newton's third law isn't true. The law of conservation of momentum states that momentum can't be created or destroyed. It can only be transferred. Another way of thinking about this is that the amount of momentum remains constant before and after a collision. So let's look at our cue ball example here. If I have this ball and it's traveling with a momentum of 10 kilograms times meter per second, and it strikes this ball, which is at rest, the initial total momentum in this initial situation, this has 0 momentum, this has 10 kilogram meter per second momentum. So our initial momentum in the whole system is 10 kilograms times meters per second. After the collision, though, this ball, in this situation, the ball comes to rest. It transfers all of its momentum to the 3 ball. So this ball is at rest, 0, and this ball now is traveling at 10 kilograms meter per second momentum. So our final momentum in the system at the end is 0 plus 10, which is 10 kilograms meters per second. So we see here that momentum has not been created and it has not been destroyed. All that's happened is the momentum has been transferred from this ball to this ball. In the initial situation, it was 10, and then it's 0. In the initial situation, it was 0, but at the end, it's 10. So we're not losing or gaining any momentum. So it's simple when we're looking at it with just one ball, but I'm not going to give you something like that on the quiz, obviously. I'm going to give you something more along the lines of this. We have this cue ball, and it's going to hit these, 6, 7, 8. It's going to hit, these were 6, sorry. I drew 8, but I meant 6 down here. So let's say there's 6 pool balls. I'll erase 2 of them. Okay, there's 6 pool balls there, right? All right, so this cue ball is going to run into this pack of balls here. All right, so it starts with a momentum of 12 kilograms times meter per second. That's the initial, and all of these are at rest. They're not moving. So the initial total momentum is 12, right? And then I told you that after the collision, after this cue ball has hit all of the other pool balls. The cue ball has a momentum of 0, so it comes to rest. It has a velocity of 0. Its mass hasn't changed. Remember that momentum is just momentum equals mass times velocity, right? So its velocity has come to 0. Its mass didn't change, but its velocity came to 0, and any mass times 0 is going to be 0. So its momentum is 0, but all of the individual pool balls that were struck now have a momentum of, I think I asked you what they would have a momentum of, if there are 6 of them. Well, the law of conservation of momentum tells us that momentum cannot be created or destroyed. So the initial momentum of 12 must be the same at the end. So it must be 12 at the end. Well, it's not here. There's 0 momentum here. So it must be split evenly amongst these 6 balls. Well, 12 divided by 6 is 2 kilograms times meter per second of momentum in each ball. All right? So this is the law of conservation of momentum. It can't be created, it can't be destroyed. Okay, then we looked at these equations, which I had you do this because I think it's good to understand the law of conservation of momentum, but you're not going to need to use these equations on the exam. So I'm going to give you a problem more like this, a word problem. You're not responsible for, you don't need to know how to solve with using these big equations. I wanted you to do this because it helps us understand the law of conservation of momentum. So if you do understand what we did here and if you were able to solve for this, then that's awesome. That means that you're not going to have any problem doing these simple problems on the quiz. But I'm not going to make you do anything involving a real calculation like we did that one day with this. Okay? So if you understood all this, that's awesome. If you didn't, I would go back and rewatch that video because it is important and it helps you understand the law of conservation of momentum, but I'm not going to give you a word problem like this on the quiz. So, aka all you need to understand is a situation very similar to this one will be on the quiz. Or it would be something like, let's give an example. Okay, so I have this boy running at 15 kilograms meters per second, and there's 2 other boys standing in his path talking, and they're looking at each other and they're not paying attention, blah, blah, and he's just listening to his music, not paying any attention, just running, and what's going to happen? They're at rest. They have 0 momentum. So what's going to happen is this boy's going to be running at 15 kilograms meters per second, and he's going to smash into both of these boys, okay? So when he does that, he sends the boys flying and they fall down. So these boys are going to be moving now. This one's going to be moving at, let's say, 8 kilograms meters per second. The first one's momentum is that. The second boy's momentum I'm not going to give to you. But the first boy who is running, he's come to a complete stop. He's come to rest. So, at what momentum is this boy moving? Well, we know that initial momentum must be equal to final momentum, right? So, if the initial momentum was 15 plus 0 plus 0, that means that that was our initial momentum. So what must our final momentum be? Well, because of the law of conservation of momentum, we know that momentum can't be created and it can't be destroyed. So therefore, this must also be 15 kilograms meters per second. So 0 plus 8 plus what equals 15? Well, this has to be 7 kilograms meters per second, right? Because 8 plus 7 is 15. Okay, so this is the type of example I'm going to give you. I'm not going to give you a problem with the boy's mass is this and he's got a velocity of this. I'm not going to be giving you problems like that. Okay? So it will be more simple like this. Okie dokie, that is it. That is the end of the review. Your quiz will be on Friday. Don't forget these things that I asked you so kindly to adhere by. I erased them. You need to submit, or you need to, I will send you the quiz at 11:50, and you will copy and paste this quiz into a separate Google document. It must be a Google Doc here. You're going to title it Q3 and your name in all caps. You're going to share it back with me by 12:50. You will not edit it after 12:50, and for every minute that you submit it or reshare it with me late, or for every minute that I see you've edited it, you will get -1 point on your quiz. If anybody has any questions regarding the information that I've gone over, or regarding this information here, please let me know. I apologize for yesterday's video. We got new internet, and I had to get a new Gmail account, and I feel for some reason that I don't understand why my videos aren't uploading, and it's not only with physical science. I'm having a really hard time uploading videos to YouTube from my computer and my iPad. So I apologize. Hopefully this one gets loaded. I tried yesterday for like 5 hours and it wouldn't upload. So hopefully this works. I'm going to try something different. So please let me know if you have any problems. Well, you've made it to the end of the video by now, so let me know if you have any questions about the information or the directions for your quiz on Friday. All right, have a good day off. Let me know if you have questions. See you.